On February 16, 1943, deep within an underground complex beneath Tunis, Obert engineer Klaus Hermann and 5 of Germany's top radio engineers prepared to examine a captured American radio set. German propaganda had consistently claimed American technology was inferior, primitive, mass-produced junk. Yet Allied forces maintained constant communication across vast distances with a precision that hinted at a far more sophisticated system. The equipment, an SCR-508 radio from a destroyed American M4 Sherman tank captured during the battle at Kasserine Pass, was about to shatter every assumption German military planners held. The truth, hidden within its circuits, would expose an industrial chasm so vast that Germany's defeat was already apparent. The capture began on February 14th when a signals intelligence detachment under Hauptmann Friedrich Weber found the miraculously undamaged radio compartment inside an abandoned Sherman tank. Inside were 2 complete intact radio sets, the SCR-508 for tank-to-tank communication and an SCR-510 receiver, complete with crystals, cables, and even the technical manual. Weber immediately recognized the value of the find and had the equipment transported to Technical Testing Station 12. The initial external examination immediately raised flags. The American radios were housed in heavy-gauge, olive-drab steel cases with rubber gaskets designed to withstand water, dust, shock, and temperature extremes that would ruin most German radios. Hermann noted in his first report that the construction quality surpassed anything he had seen in German military equipment. The real shock, however, came when they opened the cases. Inside, everything was standardized, modular, and designed entirely for mass production. There were no signs of hand adjustments or individual tuning. This equipment was clearly intended to be built by the millions by semi-skilled workers across a continent. Specialist Lieutenant Hans Schreiber focused on the crystal units, which controlled the radio's operating frequencies. He had expected simple, inexpensive components. Instead, he found precision quartz oscillators, ground to tolerances measured in parts per million and hermetically sealed. The SCR-508 utilized 10 individually packaged interchangeable crystal-controlled channels, a stark contrast to Germany, where such expensive and scarce precision crystals were reserved only for high-command units and aircraft. Schreiber calculated that a single American crystal, which was installed as casually as a light bulb, would cost more than the entire German Fugue 5 radio set in labor and materials. The Americans were installing 10 in every tank radio and had already produced thousands of Sherman tanks. The team quickly uncovered other alarming facts. The radio operated on frequency modulation, or FM, which was theoretically superior for its static-free communication and interference resistance. German engineers had rejected FM for field use as too complicated and costly. Yet here was a mass-produced FM radio installed in a tank driven by a junior soldier. The circuit board also included automatic frequency control, or AFC circuits, that kept the radio locked on frequency without the constant manual adjustments German operators needed to perform. Hermann began drafting his report to the Wehrmacht High Command, the words slowly contradicting years of propaganda. He stated that the American radio represented a level of industrial sophistication Germany could not match, requiring specialized factories and quality control systems that did not exist in the Reich. Over the next 3 days of systematic testing, their sense of dread deepened. The SCR-508's transmitter produced 25 watts of clean FM signal across 10 selectable channels. A simple rotation of a knob selected a preset crystal, automatically switching frequencies and retuning circuits with perfect transmission quality. German radios required trained operators who could spend minutes manually adjusting multiple controls to change a frequency. Range tests were equally disturbing. The FM signal remained clear over 20 kilometers without the fading and static that plagued German AM communications. The receiver's limiter circuits stripped away electrical interference, delivering clean audio that German operators could only dream of. Schreiber's detailed examination of the crystal oscillator circuits confirmed his worst fears. The system was impossible to duplicate with German manufacturing capabilities. Each crystal required specific, extremely tight tolerances, and temperature compensation circuits maintained frequency stability across a massive range. He calculated that producing one crystal to American specifications would take approximately 40 hours of skilled German technician time. With similar radios in other vehicles, the Americans were producing millions of precision crystals annually. The answer to Schreiber's question about the source of so many skilled American technicians was even more unsettling. The Americans were not using highly trained technicians. They had industrialized the entire process. New factories in cities like Chicago and Fort Wayne employed thousands of semi-skilled workers, mostly women, operating specialized grinding machines that produced crystals automatically. Quality control was statistical, and precision measurements were handled by machines, turning a laboratory art into an industrial process. The receiver section revealed superior components, manufactured to tighter tolerances than German parts. Crucially, the radio featured modular construction. Every major subsystem, transmitter, receiver, power supply, was a separate, replaceable unit. A tank crew could swap a failed module in minutes without tools or technical knowledge, ensuring American tanks maintained communication under conditions that would silence a German vehicle for days awaiting field repairs. The accompanying technical manuals confirmed this industrial philosophy. They assumed minimal technical training, using simple, numbered steps and decision tree troubleshooting guides. The Americans had decided not to train every soldier as an electronics expert. Instead, they designed equipment any reasonably intelligent soldier could operate and maintain with simple procedures. German radios, by contrast, demanded skilled operators who could perform field repairs and understood complex radio theory, irreplaceable assets whose loss often rendered their equipment useless.
The 200-page report sent to the Wehrmacht High Command was devastating. American radio technology was 5 to 10 years ahead in key areas like FM, crystal control, and modular construction. More significantly, the equipment was designed for mass production, a fundamental industrial philosophy Germany lacked. Hermann estimated that Germany would need to build 30 new specialized factories, train 50,000 workers, and spend the equivalent of the entire annual Luftwaffe budget to match American production capabilities. Even then, Germany lacked the necessary raw materials, like high-quality quartz. The conclusion was inescapable. American industrial capacity had made technological superiority militarily decisive. The response from Berlin upon receiving the classified report on February 25, 1943, was silence. The implications were too devastating to acknowledge. Over the following months, more captured equipment confirmed this superiority. The SCR-300 backpack radio, the famous walkie-talkie, was a miniaturized FM unit weighing only 18 pounds, yet providing reliable communication up to 5 kilometers. German equivalents weighed over 40 pounds and required a 20-pound external battery pack. The SCR-299, captured in Sicily in July 1943, stunned the team. It was a mobile long-range communication station, installed in a truck with an integrated power generator. It delivered 350 watts of power with crystal-controlled stability and could change frequencies in minutes. German equipment of similar capability existed only in fixed installations with building-sized antenna systems. The Americans had packaged equivalent capability into a vehicle that could be set up anywhere in an hour. The pattern was clear. American equipment was designed for minimally trained users, mass production by semi-skilled workers, and simple maintenance procedures. The German equivalent required skilled operators, hand assembly, and electronics experts for field repairs. One philosophy scaled to millions of units and global deployment, the other did not. The captured technical documentation revealed the secret behind the scale: standardization.
Components like vacuum tubes, crystal holders, and even screws were standardized across multiple radio types, allowing American factories to switch production between different models without retooling. The entire system was designed for flexibility and scale. German manufacturing, conversely, used custom components for almost every equipment type, requiring dedicated production lines and specialized inventory for each model. As the war progressed, Herman's reports evolved into strategic warnings about industrial capacity. He documented the explosive growth of the American electronics industry, where companies like Galvin Manufacturing, Motorola, and Western Electric had transformed civilian factories into massive military contractors in less than 2 years. Detroit's automotive engineers designed radio production lines with the efficiency of car assembly plants. Germany's industry, still organized like it was in the 1920s, relied on small manufacturers and skilled craftsmen, with production measured in hundreds per month, not thousands per week. Herman's December 1943 report, The American Radio Industry, documented that the U.S. industry was producing annually what would take Germany 20 years to manufacture. The gap was industrial, organizational, and philosophical. American forces enjoyed unlimited replacement equipment, retiring outdated models and replacing damaged ones without field repairs. German forces, by contrast, carefully husbanded every radio, cannibalizing parts and performing repairs under combat conditions, with newer designs remaining in limited production. The crystal supply was a particularly critical point. Germany needed 5 million precision crystals, but could only produce about 200,000 annually. Intelligence estimates showed the Americans were producing 30 million annually, having industrialized the quartz supply chain through mining in Arkansas and deposits in Brazil. The American use of automated test equipment, sophisticated electronic instruments that measured all critical parameters in seconds, was another dimension of the industrial gap. German factories relied on slow, manual test procedures requiring skilled technicians. A captured American signal generator, a standard piece of factory equipment, required a German laboratory filled with equipment costing thousands of marks to match. By early 1944, the message was terrifying. American communications superiority was absolute and growing. The introduction of American radar systems in late 1943 confirmed this. A captured SCR-584 fire control radar, examined in March 1944, operated at a very high frequency and used automatic tracking circuits, achieving accuracy that allowed anti-aircraft guns to destroy enemy aircraft with devastating effectiveness. German radar development lagged because their industry could not produce the specialized magnetron tubes needed for these higher frequencies. Each new piece of captured equipment showed continuous improvement, design refinements, and increasing manufacturing sophistication. German equipment, meanwhile, degraded in quality due to material shortages and the loss of skilled workers. By the Normandy invasion in June 1944, German intelligence knew the full picture. Allied forces landed in France with more radios than the entire German army possessed. The Allied forces maintained constant contact from the squad level to theater command through a fully interoperable network. German communications, in contrast, were incompatible and often failed under the stress of combat, with radios drifting off frequency in the summer heat and running out of batteries.
Herman, writing in August 1944, stated that Germany had already lost the electronic war. Allied signal intelligence, direction finding, and jamming equipment allowed them to locate and target any German radio transmission within minutes. The final industrial collapse came in late 1944 and early 1945 as Allied bombing destroyed radio equipment factories. By March 1945, German radio production had essentially ceased. When a German headquarters radio failed, commanders lost contact. When tank radios broke down, armored formations became isolated. The Americans, meanwhile, continued production at full capacity and introduced improved designs even as victory approached.
After Germany's unconditional surrender on May 8, 1945, the captured German technical intelligence reports provided Allied investigators with a unique perspective on their own equipment. Herman's final testament, written in April 1945, concluded that Germany's defeat was inevitable from the moment the first captured American radio was opened. The frequency crystals, automatic circuits, and modular design revealed an industrial philosophy that applied mass production techniques to every aspect of military equipment, a concept Germany could never match. Herman believed future wars would be won not by superior soldiers or tactics, but by the side with greater industrial capacity to produce high-technology equipment in overwhelming quantities. Herman and many of his colleagues were recruited by American authorities after the war, transferring German technical knowledge and, perhaps more importantly, learning the American industrial methods that had ensured Allied victory. In 1952, Herman's technical paper, Comparative Analysis of German and American Military Radio Design Philosophy, 1939 to 1945, cemented these lessons. American design prioritized ease of manufacture, simplicity of operation, and reliability over technical sophistication. German design sought theoretical perfection and component economy, relying on skilled operators to compensate for equipment limitations. One philosophy scaled to global deployment, the other did not. At a conference in 1986, Herman, then in his 70s, displayed a photograph of the first SCR-508 his team had examined. He told his audience that the moment they saw 10 precision crystal oscillators installed in a standard tank radio, he knew Germany had already lost the war. The crystal, a simple quartz wafer, represented the intersection of physics, engineering, and industrial organization. To produce millions of them to a standard, interchangeable quality at a low cost required an industrial infrastructure that America had created between 1941 and 1945, one that subsequently evolved to produce transistors, integrated circuits, and the microprocessors that define the modern world. The Smithsonian exhibit in 1995 featured the SCR-508 examined by Herman, alongside a comparable German FUG-5 radio. The curator's notes explained the difference. German equipment represented excellent engineering constrained by limited industrial capacity. American equipment represented adequate engineering multiplied by unlimited industrial resources. The final display, a single radio crystal recovered from the SCR-508, bore a label explaining that it represented approximately 40 hours of skilled German labor to duplicate, yet the Americans had produced over 100 million such crystals during the war. Herman's lifelong insistence, recorded in his obituary, was that Germany's defeat was determined not on battlefields but in factories, not by soldiers but by production workers, not through tactical failures but through industrial limitations. In a personal letter written in April 1945, he reflected on 3 years of examining American equipment, concluding that America possessed a fundamentally different approach to warfare, having industrialized everything. Germany, he wrote, had tried to fight an industrial war with craftsman methods. Theoretical knowledge does not win wars. Production capacity wins wars. The side that can build more tanks, more aircraft, more radios, and more everything will eventually overwhelm any opponent. The story of the German technicians examining the captured American radio equipment is ultimately the story of industrial warfare. It is the transformation of conflict from one determined by tactics and courage to one determined by industrial capacity and manufacturing efficiency. The frequency crystals were precision engineering scaled to mass production. This capability extended to every aspect of American military equipment. The lessons were harsh but clear. Superior individual equipment means nothing if it cannot be produced in quantity. Sophisticated technology is useless if operators cannot reliably use it. Industrial capacity, properly organized and directed, defeats everything else. These principles, design for production, standardize components, train users simply, scale to meet demand, became the foundation of modern manufacturing philosophy. The small piece of precision-engineered quartz became a symbol of the Industrial Revolution in military affairs, representing the moment when victory stopped being determined primarily by battlefield prowess and started being determined by factory outcome. The Germans witnessed, analyzed, and reported the future of conflict. The fundamental truth remains unchanged. The side with greater industrial capacity to produce high-technology equipment in overwhelming quantities will ultimately prevail.